Today, we are going to discuss a very interesting topic where science and nature come together, making nanomaterials using natural, biological methods. We call this green synthesis or eco-friendly synthesis because we use things from nature, like plants, bacteria, fungi, and enzymes, instead of harmful chemicals. This method is becoming more popular as we aim for safer, more environmentally friendly ways to make these very tiny materials, called nanomaterials. Let's start with the use of plant extracts. In simple terms, plants have natural compounds like polyphenols, flavonoids, and alkaloids that help in this process. You can think of these compounds as natural helpers that can reduce or change metal salts into nanoparticles. For example, if we want to make gold or silver nanoparticles, we can add plant extract to a solution containing gold or silver salts. The compounds in the plant extract will reduce the metal ions, creating small particles which are called nanoparticles. This method is simple, effective, and cost-friendly. And what's amazing is that different plants can create different shapes and sizes of nanoparticles, making them unique. For example, neem or tulsi extracts can produce nanoparticles with specific properties that may be useful in medicines, cosmetics, or even electronics. Next, let's talk about the use of bacteria in nanomaterial synthesis. Bacteria are tiny organisms, but they have great power in creating nanoparticles. Some bacteria can absorb metal ions from their surroundings and, through their natural processes, turn them into nanoparticles. This process is called bioreduction. Different types of bacteria, like E. coli and Bacillus subtilis, have been used in this process. For example, E. coli can be used to make silver or gold nanoparticles, which are valuable because they have antibacterial properties. This means they can be used in medical products, wound dressings, and other health-related applications. Now let's move on to the role of fungi. Fungi, like mushrooms and molds, can also create nanoparticles. Fungi are especially good at this because they produce large amounts of enzymes and proteins, which help in reducing metal ions to form nanoparticles. For example, the fungi Aspergillus niger and Fusarium oxysporum have been widely used to produce silver, gold, and even zinc oxide nanoparticles. This method is efficient and produces nanoparticles that are very stable. Also, because fungi can be grown easily, it's a very scalable method for producing nanomaterials. Finally, let's discuss enzymes in nanomaterial synthesis. Enzymes are proteins that speed up chemical reactions. Just like in our bodies, enzymes can work outside of organisms to make nanoparticles by reducing metal ions in a controlled and precise way. For example, an enzyme like nitrate reductase can help in making silver nanoparticles by reducing silver ions. The advantage of using enzymes is that they are very specific, meaning they can make nanoparticles with controlled sizes and shapes. This is useful in fields like medicine, where exact particle size and shape can make a big difference in how a drug works in the body. To summarize, with plants, we use their natural compounds to make nanoparticles easily and safely. Bacteria use their cell processes to absorb metals and convert them into nanoparticles. Fungi are powerful because of their enzymes and proteins, which can produce very stable nanoparticles. Enzymes allow precise control, creating nanoparticles with exact sizes and shapes. This field is developing fast, and with these biological methods, We are finding new ways to make nanomaterials that are safer and more eco-friendly. Whether it's for medicine, electronics, or even environmental cleanup, these green synthesis methods bring great promise.